We are starting into Unit 3, Radicals and Rational Exponents. The first lesson in Unit 3 is going to be simplifying radicals. So before we simplify them, we need to know what they are. So a radical is a symbol, and once I draw the symbol, you may see it as something else. But this is what we call a radical. You may see it as a square root, which you can say it that way for this one anyway. This piece right here is what we call the root or the index. You'll hear it more frequently be called the root. And then what's underneath, like if I put a number here like 9, we call this the radicand. So the symbol is what we call a radical, and then what's in this space here is the root. If there's no number there, it's really a 2. It can't be anything smaller than a 2 because you need two numbers to multiply together. And then this is a radicand. What's underneath the radical sign is what we call the radicand. So this is actually saying or asking what number times itself gives you 9. What number times itself gives you 9? That's why that's a 2. This has to be a 2 because in order to multiply, you can't multiply with one number. You need at least two numbers. So we all know what number times itself would give us 9. It would be 3. So given that, let's take a look at number 1. So the directions will say simplify. So let's do another perfect square. Suppose I ask you to tell me what the square root of 81 is. So your first thought should be, is there a number that I can multiply by itself to give me 81? Yeah, it would be 9. 9 times 9 is 81. If we take a look at question 2, I've got the square root of 24. Well, if I think about a number when I multiply by itself will give us 24, there isn't one. So I don't want you putting this into the calculator and giving a decimal. I probably should have put here no decimals. No decimals. So what we're going to do is we're going to find the prime factorization, meaning we're going to break down this number until we have all the prime factors of 24. So the first question I ask myself is, what is a factor pair of 24? There are several. I'm going to say 2 and 12. Then I'm going to go here. I can't break down the 2, but I can break down the 12 to 2 and 6. I said I couldn't break this down. You can't have 2 and 1, or the number in 1. The 1's not going to do us any good. I can't break down the 2. I can break down the 6 to 2 and 3. So when I rewrite this, I've got 3 2's and a 3. I'm not going to write a 6 because I've got like a branch coming from it. It's those numbers that don't actually have a branch coming from it. Now, the root is 2. Remember, if there's no number there, it's 2. So I'm trying to find 2 of the same number. Well, I've got 2 2's here. So that's that 2. And then what's left that I did not circle? So for each grouping, you're taking out 1 because 2 times 2 is 4. The square root of 4 is 2. So that's why I'm taking out 1, 2, because really the square root of 4 is 2. And then what's left here is 2 times 3 is 6. So the way I would say this is 2, the square root of 6. That's how I would say that. 2, the square root of 6. That's my answer. Okay, let's take a look at number 3. I've got the square root of 75. So I know 75 is not a perfect square. Let's break it down. When I think of 75, I think about cents, 3/4. So 3 and 25, and then 5 and 5. So I'm going to rewrite this as 3 times 5 times 5. I'm going to group the 5s together. That's going to come out. And then what's left that I did not circle is 3. So sometimes I'll be left with one number. Here, if you're left with two numbers, you have to actually multiply it together. But if it's just one number, you just bring it down. All right, let's take a look at number 4. Now number 4, the root's going to change here. I have the third root of 24. So now when I break this number down, well, I've already broken down 24, but we'll do it again. 2 and 12, 2 and 6, 2 and 3. So when I rewrite this, this becomes the third root of 2 times 2 times 2 times 3. Because the root is 3, I have to find 3 of the same number, which is right here. I've got 3 2's. So I'm going to take out a 2, and then I'm going to leave that 3 there, and then I've got what I did not circle stays underneath that radical sign. So it's 2, the third root of 3. 2, 2. Let's get rid of that. There's too many 2's there. 2 the square root of 6. I'm going to say 2 the third root of 3. Let's go to number 5. I've got, now these next couple of problems, there's going to be a number out in the front. So I've got -5 the square root of 120. So let's go break this number down. I've got 10 and 12. I've got 2 and 5, 2 and 6, 2 and 3. So I'm going to rewrite this as -5 the square root of. I've got 3 2's, a 3, and a 5. The root is a 2. So if there's no number there, remember it's a 2. So I'm trying to find 2 of the same, which is right here. So I'm going to bring down this -5, and I'm going to multiply it to the 2 that I'm taking out. And then what do I have left? 2 times 3 is 6 times 5, 30. So it's -10 the square root of 30. -10 the square root of 30. Number 6. Now number 6 is just like number 5, except it's the third root. So let's break down that 32. I've got 2 and 16, 2 and 8, 2 and 4, and 2 and 2. So I've got 6 the third root of, and then I've got 5 2's. Because the root is 3, I'm trying to find 3 of the same number, which is right here. So I'm going to bring down that 6 times the 2 that I'm going to take out, and then I'm left with the third root. Don't forget to write that 3, the third root of 4. So 12, the third root of 4. Number 7, we're doing 9 of these total, 9. Okay, number 7, I've got the square root of 10 times the square root of 6. Now, when you're multiplying by the same root, it doesn't matter what the radicand is. These are both square roots, so I can multiply these together. So this becomes the square root of 60. Let's break down the 60. I've got 6 and 10, 2 and 3, 2 and 5. So this becomes the square root of 2 times 2 times 3 times 5. I'm going to group these two 2's together. That's what I'm going to take out. 3 times 5 is 15. So I'm left with 2, the square root of 15. Let's take a look at number 8. I've got -4, the square root of 15. Times 5 the square root of 27. So I'm going to multiply what's on the outside together. I'm getting negative 20. I'm going to multiply what's underneath together. That gives us 405. Now, I just multiplied 15 to 27 to get 405, so that's the factor pair I'm actually going to use. Why do some extra work? It's there. All right, so I've got negative 20, and then I've got the square root. I've got 4 3s and a 5. 4 3s and a 5. Now this time I have 2 groups of 3s. So I've got negative 20 times the 3 that I'm going to take out times the other 3 I'm going to take out, and I'm left with the square root of 5. So negative 20 times 3 is negative 60. Negative 60 times 3 is negative 180, the square root of 5. And let's do one final third root problem. So number 9, I've got negative 2, the third root of 5 times 5, the third root of 50. Negative 2, the third root of 5 times 5, the third root of 50. So I'm going to multiply what's on the outside together. That's negative 10. 5 times 50 is 250. And I've got that third root. I'm not going to drop that. Okay, let's break down that 250. I'm going to use 5 and 50. I just multiplied those numbers together. So I've got negative 10, the third root of 2 times 5 times 5 times 5. Here's my group. I'm going to bring down negative 10 times 5, the third root of 2, which gives us negative 50. Negative 10 times the 5 that I'm taking out is negative 50, and what's left underneath is a 2. And I'm grouping by 3s because that is the root. If this said 4, I'd be grouping by 4s. And that is simplifying radicals.